non-ideal solutions with positive deviations. Now, non-ideal solutions with positive deviations are the solutions in which the solute-solvent intermolecular forces are weaker than what we have present in their individual solvent-solvent and solute-solute particles. The forces, when they are mixed, are found to be weaker than they used to be. Like, the best example I can give you in this regard is the example of ethanol when added to water. Now you can see in this case, we believe that we know that alcohol is having this, ethanol is having hydrogen bonding, water is having hydrogen bonding. When mixed together, they will also form hydrogen bonding, and they could be the one which will be forming ideal solutions. But what we find actually in the reality is that, of course, they have formed hydrogen bonding, but what we find in this case is somewhat like this. Is like this. What we find is, due to this bulky ethyl group, the water molecules are not able to come very close to each other, to these alcohol molecules, or we can say rather, these alcohol molecules have come in between the water molecules and have what has increased the length of the hydrogen bonding. As a result, the new hydrogen bonding formed is a weaker hydrogen bonding than it used to be in the between the pure water molecules. So what we find, therefore, both of the components will definitely evaporate with greater rate, because the forces between them are now weaker than it used to be in the pure state. So what we find is, that is why the partial pressure of these components were found to be more than what we can have them from the Royle's law formula. That means Pa will be greater than P naught AXA. Similarly, the partial pressure of the B component will be more than what we can have from the Royle's law formula. It will be P naught B XP. So the partial pressures are found to be more than what they used to, or they can be from the Royle's law formula, and therefore the total vapor pressure of the solution is also found to be more than what we were expecting from the Royle's law formula. Now, in such cases, in such solutions, another most important thing is that the volume of the solution is also found to be positive. It means what? The volume gets increased. There will be net increase in the volume of the solution. That means if 50 ml of alcohol and 50 ml of water are mixed, the volume of the solution will not be exactly 100, it will be somehow more than 100. It will be 101, 102, somehow it will be like this. Because molecules are moving away from each other, because the binding force between them is weaker now. So the volume is increasing. Another important thing is, what we find is the enthalpy of the solution. That the enthalpy of the solution is also found to be positive. It means what? The earlier hydrogen bonding which has been broken in this case were the stronger ones, so more of the energy was required to break them, and lesser amount of energy is released in the formation of the new weaker hydrogen bondings. So in total energy is consumed. That is why enthalpy of the solution is positive. It's an endothermic process. Let us see the px diagram of these types of solutions. We'll take the same example. This is vapor pressure, this is vapor pressure, this is mole fraction of solvent is 1, mole fraction of solute is 0, mole fraction of solute is 0, mole fraction of solute is 1, solvent is 0, solute is 1. This is your P naught A, this is your P naught B, and we are having this dotted line. Now see, these dotted lines are the expected behavior as per the Royle's law. Specifically this line, which is the vapor pressure of the solution, we were thinking that the solutions will be, if following the Royle's law, will be having the graph like this, the dotted line. But actually what we get is, we get a graph like this. We get a graph like this. This curved line is your PS now. And you can see it is found to be much more than the actual value. Even the individual components graphs were also found to be having higher value than the expected one. Why? Because the weaker were forces. The forces were weaker. And therefore, both the components were evaporating at a higher rate. And that's why the vapor pressure solution were found to be much more than the expected Raoult's law value. And that is why we call it positive deviation. So this is what is the graph is. Here we have a pure solvent, here we have a pure solute. This is the vapor pressure of the solvent in the pure state, vapor pressure of the solute in the pure state, and this is what is the graph is. Now at this graph, in this graph, there is either lies a point at which the vapor pressure of the solution is maximum. Therefore, boiling point is minimum. And this point is called minimum boiling point, a minimum boiling azeotrope. Because this is the point where what we find is that the vapor pressure of the solution is maximum. So the solution will boil at a lower temperature because its vapor pressure is higher. So that this point is called minimum boiling azeotrope point. Now if the example which we have taken, if we take that, we can draw perpendicular from this point and we can find out the composition. We'll find that it is richer in B. So what we find is at this case, even in this case, like the example we have taken, like alcohol is found to be, if we take the alcohol water example, almost 95%, and water is found to be how much? 5%. And this is what is the point is that we call it azeotropic point or minimum boiling azeotrope. So water alcohol forms minimum boiling point azeotrope at this composition, where the solution boils at a much lower temperature of 351.5 Kelvin, which is lower than the boiling point of both alcohol and water. So this is what is called the positive deviation graph or the positive deviation of the non-ideal solutions. Let us see now certain other examples of positive deviations. The mixture of methanol, water, we can have mixture of ether with water, we can have mixture of acetone with water, etc. All are the examples of your positive deviation, in which what we find is stronger hydrogen bonding of the water molecules are becoming weaker, because what happens is these other molecules gets in between those water molecules, and what they reduces the strength of the hydrogen bonding which is there between the water molecules. So this is what is positive deviation.